Okay, so for this one, we are going to review a couple things. First of all, simple stoichiometry. Second thing we're going to look at is limiting reactant. And then finally, we're going to look at percent yield that we have. Now, if I have a particular reaction, I have chosen a simple one to put on the board because I have a small board here. But let's say I have this reaction. Two aluminum atoms react with 3 chlorine molecules to give me 2 AlCl3s. Okay, if I begin with 5.40 grams of aluminum and 8.10 grams of chlorine, I have several questions. First question is, what is my limiting reactant? Which one do I run out of first? The second thing is, what mass of aluminum chloride would I expect to get? And that is going to be our theoretical yield. And finally, I have a question on percent yield, but I'll give you those numbers in a little bit. The first thing we need to do is figure out which of these two is going to be our limiting reactant. Now, I can do this a number of ways, but because I know I'm eventually going to find the mass of aluminum chloride, I'm going to start out by saying, if I use all of this up, how many moles of aluminum chloride do I get? If I use all of this, how many moles of aluminum chloride am I going to get? So starting out with a 5.40 grams of aluminum, and I know that 1 mole of aluminum is 27.0 grams, and this comes out fairly simply. Now, for my stoichiometry, I know I get 2 moles of AlCl3, if I can write that, or 2 moles of aluminum. Now, if we do this right, when I go back through, I'm going to find this is grams of aluminum is going to cancel, moles of aluminum is going to cancel, giving me moles of aluminum chloride. And when I do the math here, I end up with 0.200 moles of aluminum chloride. Now, that is not necessarily the amount I'm going to end up with. That's if I use all the aluminum. What happens if I have more chlorine? If I have an excess of chlorine, this will be the amount of aluminum chloride. However, let's see if the aluminum is the limiting reagent or if the chlorine is. So if I just do the same thing, 8.10 grams of chlorine, and chlorine diatomic, find the molar mass, take the chlorine times 2, because there's 2 atoms of chlorine. 1 mole of chlorine is 70.9 grams. And this one is not a 1-to-1 ratio. I know I still get 2 moles of AlCl3, but it takes 3 moles of Cl2. And remember, this is my stoichiometric factor, which comes from my balanced equation. This 1 mole, because it's the mass of 1 mole of chlorine. And when I do this calculation, I find out that I'm going to get 0.0762 moles of AlCl3. Which of these two is smaller? Obviously, this is the smaller value. So my chlorine is my limiting reagent. My aluminum is my excess reagent. And to find the yield that I would expect, I'm going to take 0.0762 moles of AlCl3. And I'm going to multiply that by the molar mass, which is 133.3 grams of AlCl3 in 1 mole. And this is going to give me a total of 10.2 grams. That is my theoretical yield. Theoretically, that's how much I'm going to get. Now, we know when we go into the lab, things don't always go perfectly. You get something stuck to the side or something happens, you lose some, something happens. You might get some impurity, which is going to cause it to be too high, or it might be really pure, but not all of it is there. In this particular case, if we go into the lab and we take and we find out we have 8.64 grams of aluminum chloride that I recover at the end. Now, this is called an actual yield. You only get an actual yield by going into the lab and doing it and measuring it. However, we can tell you about it in a problem. So if you're told the actual yield or the experimental yield is 8.64 grams, I can find the percentage yield, 8.64 grams divided by 10.2 grams, actual over theoretical times 100. And this is going to give me a percent yield of 84.7%. And this is a review of stoichiometry, a review of limiting reactants, and a review of actual and theoretical yields.